measuring segments. Find and compare lengths of line segments. Our learning target that we're going to be working on is how to find and compare. Two terms that we need to keep in mind: find and compare the lengths of line segments. We've been dealing with line segments. Now let's see what we need to do with them. On your purple page, that is your geometry toolbox for this unit, you are going to need to pause this movie and add Postulate 1.5 and 1.6. Postulate 1.5 is a very logical postulate dealing with what we call the Ruler Postulate. It says that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of that point. So we know that we have coordinates in the coordinate plane, but we also know that with a ruler we have coordinates. So coordinate plane is really made up of two rulers, one that goes horizontal and one that goes vertical. And that's why we call it a coordinate plane. So you want to add Postulate 1.5 as well as Postulate 1.6 that says segment addition postulate. If there's a point, 3 points, A, B, and C, and they are what we call collinear. Collinear is a term that means in the same line. So collinear points, they are 3 points that can lie on the same line. So if 3 points A, B, and C are collinear in the same line, and B is between A and C, then we know that AB, this segment, plus BC, plus this segment will equal AC, the entire segment. Pause the movie now and add these two postulates to your purple page. It's on the back of your purple page. Now that you've added those two postulates, we're going to look at the ruler postulate. It allows you to measure lengths of line segments using a given unit and to find distances between points on a number line. So the distance between points A and B is what we say the absolute value. That means it has to be positive because we know that distance is always positive. So we take the absolute value to make sure that it is positive. So absolute value of the difference, another term, difference means subtraction of their coordinates. So if I'm finding the distance between A and B, I would find their difference, subtract A minus B inside, and then take the absolute value. This value is also known as AB. Now this is what I call notation. This is how you write it. This means the distance between A and B, or we say the length of line segment AB. So we're going to do that right now. So in looking at this, look at our number line. We have 3 points, T, R, and S. And it asks us in the first question, what is, and notice how the capital R is right next to the capital S. What does that mean when we have two capitals right next to each other? It means the distance between R and S. So two capitals right next to each other. Notice there's no line segment notation above it and there is no line above it. So it means the distance between R and S. So we know that the R coordinate is located at -3. We know the S coordinate is located at 4. So to find RS, what we do is we do -3 minus 4, which is -7. Then take the absolute value of -7 because distance is never negative. And we get 7. Now you may be thinking, well, can I go and count on the number line and go 1, 2, 3, 4, 5, 6, 7? And the answer to that is yes, but there's some things that I want you to notice. First of all is the notation. Second of all, distance is never negative. It's always a positive value. So even though the numbers may be negative, your distance will always be positive. That's why we take the absolute value and find the difference. So go ahead and pause this movie, and I want you to do these two things. I want you to find what is ST and what is RT. They're located down here. What is ST and what is RT? Pause the movie, then press play when you're ready. ST, capital X, or S next to capital T. We know S is located at 4, and we know T is located at -8. So I find the difference between these two, which is 4 minus a -8, and then take the absolute value. 4 minus a -8 is the same thing as 4 plus 8, and that is the absolute value of 12, which is 12. Yes, you could count that on the number line. RT, R is at -3, and T is at -8. -3 minus a -8 is -3 plus 8, which is 5. So I'm taking the absolute value of 5, which is 5. It stays positive because it is positive. Finding the distance on a number line using postulates. Now we're going to throw in some algebra with that. If AC is 120, what are AB, that is the distance between A and B, and AC, that is the distance between A and C? So we know that AC is 120. I like to label that on the diagram so that I have all the information up there. So I want you to pause this movie, try this on your own, and then press play when you're ready. Using our segment addition postulate, I know that AB plus BC equals AC. So AB plus BC equals AC, using my segment addition postulate. So because of that, I know that AB, which is 4x plus 6, plus BC, and BC, which is 7x plus 15, will equal AC, which is 120. So I'm going to add these like terms, do the algebra. These two like terms give us 11x. And then I have these two like terms, 6 plus 15, which gives me 21, equals 120. So now I'm going to subtract 21. And I'll start to do this algebra shorthand. Right now I'm going to keep it showing my work. 120 minus 21, I get 99. Then I'm going to divide by 11 and get 9. Now x is 9. Be careful. It doesn't ask what x is. It asks us what is AB and what is AC. But I know that x is 9. AB I know is 4x plus 6. So I'm going to do 4 times 9 plus 6. And so I know AB is going to be 42. I'm going to do the same with AC. Now AC, I don't need to do anything. Look at that. Trick question. AC is 120. Now, it could ask for BC, in which case I would have to do 7 times 9 plus 15. But it doesn't. When numerical expressions have the same value, you say that they are equal. And we use this symbol right here, equal. If two segments have the same length, then the segments are said to be congruent, which is really an equals with a squiggly on top. So be careful. When we're talking about numbers, numerical expressions, we say that they are equal. And when we're talking about lengths of things, we say that they are congruent. It's a subtle difference, but in geometry, you're going to want to know that difference. So pause the movie and add that idea to your toolbox. Okay. Let's look at this guy. Here we've got a number line, and what we want to know is are the length of TR, which is right here, TR, and SV congruent. And we could count them. 1, 2, 3, 4, 5. Whoops. 1, 2, 3, 4, 5. It looks like they are. Let's see mathematically. TR is really 5 units because -8 minus a -3 gives us 5. And SV is really 5 units. So by the definition of distance, we say that TR, the distance between TR, is equal to the distance between SV. So the length of TR is congruent to the length SV. Because the distances are the same, we know that the lengths are the same. So a little subtlety just to show you where that's coming from. Answer this question. Are UW and RV congruent? Pause, try it, and then press play when you're ready. They are not congruent. You can tell by the number line. So we say that UW is not congruent to RV. All right. The midpoint of a segment is a point that divides a segment into two congruent segments. A point line ray or other segments that intersect a segment at its midpoint is said to bisect the segment. So to bisect is to cut in half. When you bisect something, bi is a prefix for two, and sect means to cut. So you're cutting something in half. So that point line ray or segment is called a segment bisector. In this diagram down here, you see XY segment has a midpoint A. At that midpoint, line L is going through A. So we say A is the midpoint of XY, and we show that with this notation. These two bars right here show that that line segment is congruent to that line segment. And because both sides are congruent, A is the midpoint. So we say that line L is a bisector of segment XY. You can pause, bisector, midpoint. Those are terms that you'll need to know. Add to your toolbox and press play when you're ready. U is the midpoint of TV. Are TU, UV, what are TU, UV, and TV? Meaning the distance between TU, the distance between UV, and the distance between TV. Pause the movie, try this, press play when you're ready. All right. Knowing that U is the midpoint, I know that this line segment is congruent to this line segment. So I know that 8x plus 11 is equal to 12x minus 1. Knowing that, I've got an algebraic equation. I want to get the x's on the same side. So I subtract 8x on both sides. And then I'm going to add 1. And I get 12 equals 4x. Dividing by 4. Oops, not 14. Dividing by 4 gives me 3. Oh, I don't know why that happened. don't know why I get little curlies on the floors, but I do. So 3 equals x. That helps me because I'm going to plug that back in. So I'm going to plug 3 in for x here and 3 in for x here. So knowing that, I get 8. Let's try this. I get 8 times 3 plus 11, which is the length of TU. I should label that. So TU, 8 times 3, 24 plus 11, gives us 35. So TU is 35. And then we also want to look at UV is 12 times 3 minus 1. I don't know why the writing is all off. All right, UV is 35. Now that should be no coincidence because this is the midpoint. So if this is a length of 35, then this also has to be a length of 35. Which leaves us with TV, the entire length will need to be 70. So we've answered the question. We see that it makes sense to the problem. And that's how you look at line segments. And that's going to be the end of this movie. And we've reached learning target 3.